Hey everybody. I did not think we would have to do this again this week, but here we are. Okay, so just a heads up, everything from last week and this week will be due next Tuesday, so including the Chapter 7 test. The assignment sheet for this week, along with all of the PDFs for the notes from 8.2 and 8.3 are uploaded to the portal. So what I would do before you start this is go print those notes, and that way you can follow along with me as I'm going through the lesson. I'd intended to give a quiz over 8.1 today in class, but obviously we can't do that. So we're just going to go over the quiz together. If you want, before I start the quiz, you can maybe attempt it yourself and then resume the video and you can grade it to see what you need to study. So anyways, we're going to skip the warm-up because this is basically just the quiz. So let me get over here. Okay, so the quiz just had 3 questions from 8.1 over direct and inverse variation. If you haven't watched that video from last week, please go do that and make sure you've taken notes because the stuff we're going to learn in 8.2 and 8.3 build on 8.1. So let's look at this first question. So it says, determine if the table shows direct variation, inverse variation, or neither, then write the equation for inverse or direct variation. So remember the difference between direct and inverse. So if I have a direct variation, I can write the relationship as the product of k and x. And that means as x gets bigger, so will y. And on the other hand, if it's inverse, I'm going to have k over x, which is the opposite relationship, or it could be neither, meaning this table doesn't fit either type of relationship. Okay, so I can see in the table, so for 2, I have an output of 36. At 9, it is 8, and it's kind of jumping around here. 3 is at 24, and 6 is at 12. Okay, so let's do ourselves a favor. Let's rearrange this so that this is going to make more sense, and we can see if it fits into one of those equation formats. So we've got 2, 36, 3, and 24. So I'm just writing them in order. 6 and 12. And then the last one is 9 and 8. Okay, so if I think of each of those pairs, okay, in one of these formulas, so if I had 2 for x and 36 for y, so I'd have 36 equals k times 2. And then for the next ordered pair, I'd have 24 equals k times 3. For the next one, I would have 12 equals k times 6. And then for that last one, for 8 and 9, oh, you know what? I wrote that backwards. This should be 8, 9. 8, 9. Okay, sorry about that. So for that last one, I would have 9 equals k times 8. Let's make sure I didn't make any mistakes there. Okay, so for that first pair, I could see k would have to be 18. For the second pair, k would have to be 8. So I can already see this is not going to be a direct variation. Because the x and the y's, there's no correlation. They're not increasing by the same amount each time, okay? And then now we're going to try to see if we can set up an inverse variation equation that would fit the data, okay? So this time, instead of y equals kx, we're going to use y equals k divided by x and see if there's any k that's going to work for each set of points, okay? I don't think it is, but let's check. So we're going to have 36 equals k divided by 2. 24 equals k divided by 3. 12 equals k divided by 6. And then 9 equals k divided by 8. So I can already see none of these k's are going to be the same thing. Okay, so this would actually be a situation where it is neither inverse nor a direct variation. Okay, so the next thing we're going to do is we're going to write the function that models the variation described below. So this is going to be one of those situations where we have the combined variation. It's a joint variation. So it says z varies inversely with the product of x and y. So when I see the word inverse, I'm thinking denominator of the fraction. So what this is telling me is z varies inversely with the product, meaning multiplying x and y. Okay, so there's some k that's part of that inverse variation, and it tells me when x equals 2 and y equals 4, z is equal to 0.5. So what we're going to do is we're going to plug that in, and that's going to tell me the k. All right, so we have 0.5 for z equals k over 2 multiplied by 4, which, let me erase that. If you're lost here, I'm just plugging in these values and I'm going to solve for k. That way I know what the function will look like. Okay, so this is 0.5 equals k divided by 8. I'm going to multiply both sides by 8, and I get k is 4, because 0.5 times 8 is 4. Okay, so we did that work because we want to know what the function is. So I know z varies inversely with the product of x, y, and now I know that my constant of variation, that number, that k, is 4. So this is the function. Okay. All right, and then this last problem says each ordered pair is from a direct variation. Find the missing value. Okay, from a direct variation. That means I can express that relationship as the product of some constant with the x equal to the y. Okay, so let's use that first set of ordered points since we know both. We're going to use that in the direct variation formula, and that's going to tell me k. All right, so I've got 6 equals k multiplied by 4, which means k is 6 divided by 4, which is, if I divide the top and the bottom by 2, I get 3 halves. Okay, so let me go back and erase that, just so I have enough room. So we just found that k is 3 over 2. That means for that second set of points, I can use that formula y equals 3 over 2x to find my x value. So I know y is 3. I know k is 3 over 2. So I can see right here, if x is 2, I'll have a 2 on the top, 2 on the bottom, and those will cancel out and leave me with a 3. So x would be 2. Okay? And then that second question, again, we're going to do the same thing, but this time we're going to use the second set of points. So y equals k times x. I'm using 1.5 and 4. Okay? So if I divide, we could also write this as 3 halves. So if I divide both sides by 4, I'm going to get k is equal to 3/8. Okay? So that means my equation is 3 over 8x. Okay? So I'm going to plug in, I don't know my x value, I do know the y is 12, so 12 equals 3/8 times x. So I'm asking myself, what value of x is going to give me a 12 here? So if I multiply both sides by 8, 12 times 8 is going to be 96, and then I'm going to divide that by 3. So 96 divided by 3 is 32. So x would be 32. Okay? So like I said earlier, if you wanted to take the quiz by yourself and then grade it, now's a good time to stop and do that. Okay, so we are going to be taking notes over section 8.2. So like I said, I would make sure you have those notes printed. The format is on, the PDF is on the website. And I would do that because there's a lot of graphing, and it's going to be hard to draw that by hand if you just take notes on a sheet of paper. Okay? All right, so 8.2 is all about reciprocal functions. So if you think of the word reciprocal, that means like if I have 1/2, the reciprocal of that is going to be 2 over 1, which is just 2. Okay? So the reciprocal function is an inverse variation. So think about y equals k divided by x. Oh my gosh. Oh, my spelling. I don't know why I wrote it that way. Variation. So that means it's going to be of the form y equals k over x. Okay? So when we use function notation, we write this as f of x equals 1 over x. So this is like the parent function, the most basic reciprocal function. So just like we talk about a quadratic or a linear or an exponential function, this is its own function family that has its own unique graph. Okay? One important thing to note about this, x cannot equal 0. Okay? And that is because we can't divide a number by 0. So anytime you're thinking about a reciprocal function, remember x cannot be 0. There cannot be a 0 in the bottom of that fraction. Okay? All right, so what we're going to do is we're going to look at this graph. So what I want you to do is pause your video really quickly. Go into your calculator, type that in, and I want you to fill in your table, graph it, tell me the domain, range, and where you see the asymptote. There is more than one. Okay? Take a second to do that. Pause the video, and then we'll check it together. Okay. So you should have gotten, for your table, -1/3, -1/2, -1. I skipped 0 because it will say error. And we'll see why in a minute. So 1 is 1, 2 is 1/2, and then 3 is 1/3. Okay? So, like I said, there's no value at x. That's an error because we can't divide a number by 0. So on our graph, that's where the asymptote's going to be. Okay? So I'm not going to be too picky about where I put my points here. I'm just getting a good sketch of my graph. But I should have something like this going on. And then the right side of my graph, this is going to look like two different lines, but that's because there's an asymptote. Okay? So at 1, I've got 1. At 2, I've got 1/2. So this is what's happening here. Okay? So that is the basic form, the most basic form of a reciprocal function. So I have an asymptote both on the x-axis. Okay, so I have an asymptote on the x-axis, and then I also have one, I also have one on the y-axis as well. All right, and remember, an asymptote, it is where the line gets infinitely close but never actually equals that amount. So both of these lines get really close to the x and the y-axis, but they never actually cross it, meaning it doesn't have any x or y intercepts. Okay, so my domain is everything except the number that makes this 0. So in this case, the domain is all reals except x equals 0. So I have to take that 1 point out because that's where that asymptote is happening. Okay? So likewise, the range is all reals except y equals 0 because there's no value that I can plug in for x that's going to give me a 0 out of that function. If you looked at your table, you can see that can't ever happen. Okay? So that's my most basic form of a reciprocal function, and now we're going to look at what happens as we do transformations to the function. So how do we move it left, right, up, down? How do we flip it? What we've looked at with all the functions we've studied before. So let me move this up here. Okay, so the general form of the reciprocal function family, like I said, the parent function is 1 over x. But when I think about my transformations, I have a, that's my top number, x minus h plus k. All right, so this, remember, Anything happening inside to the x value has a certain effect on the graph. Likewise with k and with a. All right, and one thing to keep in mind, like I said earlier, x minus h cannot equal 0. Okay, therefore, x cannot equal h. Okay, that's where my asymptote's going to be on all these functions. Okay, all right, so like we did on the last one, I want you to pause the video, type this equation into your y equals in your calculator, find that table, and then I want you to graph it. I want you to tell me the x-intercepts, the y-intercepts, and the asymptotes. Okay, and tell me the domain and range. So let's pause, go ahead and do that, and then we'll come back together and check it. Okay, so in your table, you should have gotten -2, -4, -8, 8, 4, and 2. Okay, so when I graph this function, what I'm going to notice is these points. That last graph, they were super close to the x and the y axis, but when that top number, when that a value gets bigger, what's going to happen is those points are going to move further away from the x and the y axis. So let's look at an example. So when we graph that first coordinate at -4, -2, I can already see that's further away, okay? And then when I move over to -2, -4, again, these are pretty far away from the x and the y axis. I can't fit those other points. So the 8s I can't fit, but I'll skip over to 2. 1, 2, 3, 4 on the right side. And then at 4, 2. So again, I can see those points got further away from the x and the y axis. Okay? So my asymptotes didn't change, so I still have asymptotes on the x and the y axis, okay? So I can see that they're still approaching those, but they won't cross, meaning there are no x and y intercepts on this graph. Sorry, my handwriting's horrible. And then my domain is all reals except, remember, it can't be 0. And then my range, same thing, all reals, but it cannot be 0. Okay, so this graph is really similar to the one we just looked at, except my points kind of moved out away from the x and the y. There's still an asymptote there, but it's just going to take me a little longer to get close to those axes. Okay. All right, so what we're going to do on the next part of the notes, so this is when we're going to start exploring transformations. So what happens when I change these different parts of my equation? So what's going to happen, as I change A, H, and K. That's what we're going to look at for these next couple of slides. So what I want you to do, on your graphing calculator, I want you to fill in each of these tables, okay? So you're going to fill in 1 over x, 1 over x plus 3, 1 over x minus 2, and write all those points down. And then I want you to grab 3 highlighters, 3 color pencils, whatever, and I want you to highlight each of these equations with those different colors. And what you're going to do, after you've filled in those tables and you've color coordinated them, you're going to graph each one in the color that you chose on the graph below. Okay, I don't have it on my slide, but you have it in your notes. And then after you've done that, I want you to think, okay, as these things changed, as I added 3, as I subtracted 2, how is that affecting the graph? Okay? So go ahead, take a minute, pause the video, and then we'll come back and then fill in the table. All right, so for that first graph, this is the parent function. You're going to have negative 0.25, negative 1, negative 4. Probably is going to say error on your calculator. 4, 1, and then 0.25. Then for that middle table, you should have gotten 2.75, 2, negative 1, error again. and then 1, 4, and 3.25. And then for this last one, you're going to have negative 2.25, negative 3, negative 6, error, 2, negative 1, and then negative 1.75. Okay? So what we're going to do now is I've already graphed these. And we're going to look, I want you to make sure that you graphed each of these correctly. If you look over here, down here, this is the key. So that first graph is in red, my parent function. So look at your first graph, whatever color you chose. Okay, I'm going to highlight this on the graph so you can see it. So this is 1 over x, okay? And then the blue function is 1 over x plus 3. So comparing that to the red, I can see that it got further, it moved up, okay? So if you think, all right, where is the asymptote on that blue function? Since the blue function is now crossing the x-axis, so if you look right here, you can see that, see how this is now crossing? That means my asymptote moved up, okay? And if you think back to when we did transformations, anytime we add or subtract on the outside of the function, that moves it vertically up and down. So that makes sense that now my asymptote is moved up, okay? The asymptote in the middle has not changed because there was no horizontal transformation, but my horizontal asymptote did change, okay? All right, so if adding 3 moved it up, I can anticipate with that last function. So when I subtracted 2, that means that my horizontal asymptote is going to shift down. So let's look at the green function. Okay, so when I look at the green, again, I can tell my asymptote shifted down the same amount as what I subtracted. Okay, so take a minute, compare those graphs. If you want, it might be a good idea to maybe use a highlighter and draw where the new horizontal asymptote is and see if you can make any connections with the equation. Okay, so take a minute and do that. Okay, so in your own words, I want you to describe what happened to the graph when the k was changed in the equation, okay? So k, so a positive k, is going to move the horizontal asymptote up by however much it added. So if it added 3, the new horizontal asymptote is going to be at 3. If I subtracted k, that is going to move the horizontal asymptote down. Okay? All right, so now that I have explained what to do for that first one, now we're going to look at what happens when we add or subtract inside parentheses, or I'm sorry, inside in the denominator with the x. So again, what I want you to do is fill in that table. I'm not going to fill it in on this screen. I'm going to show you the graph on the next. But take a minute, go ahead and pause, and then fill those in. Okay? Also, make sure when you type this in that you are putting the denominator in parentheses. Okay? All right, so now looking at these graphs, again, I can tell compared to that first function, okay, so this is my first function right here. All right? My graphs did not shift up and down, they shifted left and right. So let's compare the red and the blue functions. So let's look at this one. So I can see compared to the red, this function has shifted right, and this has changed my vertical asymptote. Okay? So this is it's weird to think about. So as you shift the function left and right, it moves the vertical asymptote. So the new asymptote is now at 2. Okay? And then as I move the other direction, so if I look at the green function, this one didn't move right, it moved left. Okay, so my vertical asymptote has shifted to the left. Okay? And I can see, if you look at that connection, my new vertical asymptote is right here at -1, which it's adding 1 in my equation, but the new asymptote is at -1. So what's happening here is adding, subtracting is going to move that function left and right, okay? So let's go ahead and describe what happened when we changed our value for h, okay? So h, okay, is the new vertical asymptote. And don't forget, just like we've seen before, the h moves in the opposite direction. So meaning if I have x minus 2, that means the new vertical asymptote is at +2, okay? And vice versa. So if I had x plus 2, that would mean the new vertical asymptote would be at -2, okay? All right, and then the last transformation we're going to look at is when we change the top number. So what happens if the numerator is not 1? So again, pause the video, type these in your calculator, fill them in here, and then we're going to explore the graphs on the next screen. Okay, so now we're going to look at the graphs when we change the a value, okay? So looking at my parent function and the blue function, I can see that when the a value got bigger, went from 1 to 2, my graph got further away from the x and the y axis, okay? And then I can see with that last one, not only did it get further away from the axis, but since I had that negative out in front, so with the purple function, I have a negative and my a value got bigger, okay? It flipped and it got further away from the x and the y axis, okay? My asymptotes have not changed at all. Nothing shifted. It just changed the shape of the line. It's a stretch or a compression, okay? All right, so let's describe what happened there. So describe what happened to the graph when the a was changed in the equation. What does a -a do to the function? Okay, so an increase in the a value, meaning it gets bigger, is going to move the graph away from the x and the y axis. This is called a stretch. It's stretching away, okay? And then if a decreased, if it got smaller, it's going to move the graph closer to the x and y axis. And that's going to be called a shrink, okay? Because it's shrinking towards those axes, okay? All right, so now what I want you to do, you're going to look at each of these functions. Okay, you're going to ask yourself, what was the vertical change? What was the horizontal change? Did I get a stretcher? Did I have a stretch or compression? And did anything flip? Okay, so we're going to go through each of those transformations, and then I want you to graph it. You can use your calculator to check. Tell me the domain and range, and then where the new asymptotes are. Okay, so pause. I want you to just try that, and then we'll come back and check these together, okay? All right, so looking at number 5, remember, I'm always comparing this to the parent function, okay? So my parent function has an asymptote on the x-axis and the y-axis, okay? But I can see in my equation right here, see how we added 1? What that means is my new vertical asymptote is going to be at -1. So I'm going to draw that on my graph. That means that this is now an asymptote. Remember, it moves in the opposite direction. Okay? And then likewise, my outside transformation, the -2, is going to shift the whole function down 2. So that means I now have a horizontal asymptote at -2. okay? And then my last transformation is the 3, which is going to move my points away from the new asymptotes, okay? The new axes, if you want to call it that, okay? So if I were to type this in my calculator to just get an idea of where those points are, I can actually do this on my screen. Let's look at our graphing calculator. Let's see if it'll load for me. Okay, maybe not. I'll just type it in on mine. Let's see what we've got here. So I'm typing this into my y equals on my calculator. So I've got 3 divided by parentheses. Actually, I'm going to do parentheses around the whole thing. 3 divided by parentheses x plus 1 parentheses minus 2. So in my table, let me put this in black. All right, so in my table for my x and my y's, I've got -4, -3, -3, -3.5, -2, -5 at -1. That's my error because that can't, if I plug in -1 right here, that's going to give me a 0 in the denominator. So that's why it says that. All right, and then after that, at 0, I've got an output of 1, -0.5, 2, -1. So I think this gives us enough to make a graph, okay? So at -4, it is going to be down here at -3. And then at -3, it's at -3.5, so I can see it bending. -2 is down here at -5. Okay, so I can see that asymptote happening. I'm sorry, my graph is so bad. My pencil's not working super well. All right, and then on the other side, on my right side of the graph, I've got a point at 0, 1. That's going to be right here. And then at 1, -0.5, which is going to be right there. And then at 2, -1, so I can see my bend happening. Okay? So that is my new graph. All right, go ahead. I want you to do the same thing with that one on the right. And this is very similar to this graph, except I'm going to have a shift up instead of down. So that blue line is going to move up. Okay? So I'm going to end the video here, and then I'll make a separate video for section 8.3. But go ahead and finish up number 6 and then check it with your calculator.